everyone, if you're watching this lesson, it means that you'd like to learn more or at least recap what you've previously learned about energy transformations in a pendulum. So for this video, we're going to go over the basics of pendulums, including where the energy transformations occur, and then we'll go through a couple of example problems, one of which is from the 2013 exam, and another one which is from our workbook this year, which is actually a step above what I've seen in past exams, so that might be good news for some of you who are feeling a bit iffy about this topic. So to start off with the basics, the idea with pendulum is that you're always going to need to calculate the total energy of the pendulum system. And it's important to keep in mind that the pendulum system always has the same energy at every point. It's a matter of what ratio the energy is in gravitational potential energy versus kinetic. Now, there are 2 points within the pendulum that you can actually calculate the total energy. The first is the highest point, which is one of these points on the left or on the right. Usually it's on the left. Now at this point, the energy in the system is 100% gravitational potential energy with none of the energy stored as kinetic. This is because either the pendulum is being manually held up by someone's hand or it's in the point where it's at that split second before it starts to swing back to the other direction. So to calculate the total energy of the system, you would calculate the gravitational potential energy based on a height value. So this is the height here, and that value would be provided for you in the question. The other place to calculate the total energy is at equilibrium, which is at this point here where the pendulum is completely vertical. To calculate that total energy, you'd know that at that point, all the energy is 100% kinetic, with none of it being stored as gravitational potential energy. So you'd calculate the kinetic energy based on the velocity at this point, which is another value that you'd actually be provided in a question. So if you're given one of these problems and you're asked to calculate the total energy of a system, even if you're not specifically asked to do it, you will need to do it. These are energy transformation questions, so you need to transform from gravitational to kinetic or vice versa. But in order to do it, look to the information that's provided in the question. They're either going to give you a height or they're going to give you a velocity. If you're lucky, they're going to give you a mass, but luckily for you, you don't always need the mass. Now, if you want the total energy, you calculate the gravitational potential energy at the highest point or the kinetic energy at equilibrium. Now both of these are always going to be equal to each other, and this is where the trick often comes with a lot of people. Remember that no matter which one you're calculating, they both equal the same value. Now here's our problem question to do with the 2013 exam. This is part of the multiple choice question, and it is in 2 parts from question 3 and 4. Questions 1 and 2 in this exam actually refer to the same problem, but they are basic theory questions and I'm not going to go over them in this lesson. So just to summarize, a girl swings from a rope as shown in the diagram. At time equals t, which is the start, she's at the position x, the highest point of her motion. The girl in the swing has a mass of 50 kilograms and at position x is located 1.25 meters above y. Which of the following is the best estimate of the girl's gravitational energy at x? You are given 4 multiple choice questions, which I haven't put in here because they're not really relevant to this video. If you'd like, open up the exam and follow along. Now, of course, the first thing we're going to do is we're going to check all our units. The units we've been given, kilograms and meters. Those are both correct, so we don't need to do any changing around here. Now the mass is useful because we don't have to summarize what mass happens to be. We actually have a value. We also have a height. It's a little bit high, but that height is 1.25 meters. Now the fact that you've been given a height should scream out to you this is a gravitational potential energy question. Plus, luckily for you, they've actually specified what type of energy they'd like you to calculate. So this is dead easy. So you should know that your formula for gravitational potential energy at point x is equal to mgh. Our value for mass is 50 kilograms, our value for g is our constant at 10, and our height is 1.25 meters. So plugging those in, you get a gravitational potential energy of 625 joules. This is pretty straightforward, but the reason I go through it is because you're going to need it for question 4. So question 4 states, which of the following is the closest estimate of the speed of the girl at y? Now when we're talking about speed, that's got to scream out kinetic energy. So at some point we're going to have to switch out from this gravitational potential into kinetic. Now you know at point y, which is the point talked about in the question, this is our equilibrium. So therefore the total energy of the system is equal to mv squared on 2, which is our formula for kinetic energy. Now for the previous question, we know what the gravitational potential energy is at x, which is also where the total energy is to be found. We have already calculated the total energy of the system, which is equal to 625 joules. So that 625 joules is going to be equal to that mv squared on 2, because they're both at our highest energy points and they're both going to be equal to each other. So in this case, 625 joules is equal to mv squared divided by 2. Now putting out our value for mass being 50, our value becomes 50 times v squared divided by 2. Rearranging with basic maths means that v squared is equal to 625 multiplied by 2 divided by 50. And that gives us a v squared value of 25 and a v value of 5 meters per squared. And that happens to be, if you're checking the multiple choice answers, is actually multiple choice answer D. Now here's a problem that comes out of the workbook. Now if you can do this, this is probably about as tricky as a pendulum question is likely to get. So if you're at this level, you're going to be fine for the exam. And again, if you like to flick back to the workbook, there's probably a couple of other questions in there, and please follow along if you like. Now in this situation, a pendulum is dropped from a position shown 1.25 meters above its equilibrium position. What is the speed of the pendulum bob as it passes through its equilibrium position? Now take a note here. This value, 1 meter, is a red herring. You don't need it at any point in your calculations. In fact, the length of the string should not show up anywhere in your problem. So if you see it, don't panic, it's not relevant. What is relevant is this number here, which is our height value. Now, doing our pre-check on units, we have our units in meters. That's the only unit we've got, and we're all good to go. Now, we have a height, and we want to, at one point, calculate the total energy of the system, and the only way we can do it at this point is going through gravitational potential energy. So we plug in our values for gravitational potential, which is equal to mgh. Now, in this case, we don't have a value for m, but that's not always a problem. Just run with it if you don't have an obvious value. So in this case, mgh is equal to mass times g, which is our standard of 10, and our height is 0.25 meters, which gives us a value of 2.5 m. Note that that m is not meters, that is m that represents mass. Okay, now that's the only value we have, but that is the total energy of our system. Now, we also know at the equilibrium point, which is this point here, and that is the point referred to in our question, we know that the total energy is mv squared, which is our formula for kinetic energy. Because again, back to our theory, we know that the total energy at this point of equilibrium is equal to the kinetic energy, which is mv squared on 2. Now, knowing that the GPE at the start is equal to the kinetic energy at the equilibrium, we find that 2.5 m is equal to mv squared on 2. Now, luckily for us, we can eliminate m to give us 2.5 equals v squared on 2. Now, it's a simple matter to rearrange the formula to give v squared equals 2.5 times 2. So v squared actually equals 5 and gives us a velocity of 2.24 meters per second. Okay, thanks for watching this video, everybody. Questions and comments in the section below. If you've got any other things you'd like me to cover on videos, please let me know. Also, feel free to comment on if this video is any good or not. And see you girls in class.